The instructional part of this video is going to be short and sweet. I'm going to quickly go through each example and give the answers to the Check Your Progress problems. It should be less than 15 minutes. When the video is over, there will be a second optional section that contains a thorough explanation of each Check Your Progress problem. Fast forward to the problem that you do not understand and hopefully your question will be answered. Here we go, operations on functions. The operations on the functions are addition, subtraction, multiplication, and division. In the center, you'll notice that they're showing you the notation. Over to the right, they're showing you an example. To understand the example, you need to realize that f of x is 2x and g of x is negative x plus 5. So for addition, they simply add 2 of x and negative x plus 5 and simplify. For subtraction, they subtract. Notice that they're using the distributive property and simplify. For multiplication, they're using the distributive property again. And for division, there is no further simplification possible. Also notice that they define that x cannot equal 5 because you cannot have 0 in the denominator. Okay, let's look at example 1. In example 1, f of x is equal to x squared minus 4 and g of x is equal to 2x plus 1. First of all, in example A, you are supposed to add the two functions. So they simply took f of x and added g of x. Notice how it looks over here on the left. X squared minus 4 plus 2x plus 1. Combine your like terms. There's 1x squared, there's 2x, and then there is negative 4 plus 1, which equals negative 3. In example 1b, we are subtracting, and so we take x squared minus 4 and we subtract 2x minus 1. Remember to use the distributive property, and we combine our like terms. Let's do the Check Your Progress. Here they are. Give them a try, pause the video, and then check your answers. Here are the answers. Remember, if you want a more thorough explanation when the video is over, just keep on listening, and each one will be thoroughly explained. This next little piece of reading, they're trying to help you understand what happens when you actually add two functions. The first function that they're talking about is f of x equals x squared, and the second one is g of x equals x. So they're taking the y values for each of these, the 4 and the negative 2, and when they add those two functions, they get a new value there at negative 2, and that's what you plot. If you look at the graph, x squared has the y value of 2, which is right here, of 4, which is right here, and y equals x has the value of negative 2. When you add 4 and negative 2, you end up with 2, which is plotted on the new graph. The solid line here is the new graph. So basically, when you're adding functions, you're adding their y values and plotting them with the x values that coordinate. Same with subtraction, only you'd subtract instead. In example 2, they're looking at multiplying and dividing functions instead of just adding and subtracting them. They have f of x is equal to x squared plus 7x plus 12. G of x is 3x minus 4. First of all, they're multiplying them, and so when they do that, we've been doing this right along. You have to make sure that you're multiplying 3x times each of these first three, and then negative 4 also times each of the first three, and then combine your like terms. This is nothing new. For division, notice that they're not really dividing. They're just kind of writing it like that. They're also saying that x cannot equal negative 4/3. Why not? Because we cannot let the denominator equal 0. If you're not sure what x should be, you can take negative 3x minus 4, set it equal to 0, and solve, and you would get 4/3 negative, and that is what x cannot equal, because if it does, it will equal 0. Let's try the Check Your Progress. Here's the Check Your Progress. Pause the video and give them a try. Remember, if you want more explanation, it's at the end of the video. Compositions of functions is rather interesting. Go ahead and read it, but I also want to explain what they're talking about. What they're talking about is taking two functions. Let's take x squared, for instance. What kind of numbers can I put into x squared? Well, I can put any real number into x squared, but what am I going to get out of x squared? I am only going to get positive numbers that are greater than or equal to 0. Now, because that's what I got as my result, that's what I'm putting into the x cubed. And when I cube them, what am I going to get out? The same thing. They'll just be greater than or equal to 0. If I were to graph this function, my answers would only be greater than or equal to 0, so I would only be getting the part of that cubic curve that's in quadrant 1, like that. That would be my graph because it has to go through both. Here's a note. This is the notation. Notice that whatever you do first is closest to the x, and then whatever you do second is farther away. All right, now let's look at that key concept box. So what they're saying in this key concept box is basically like what we just talked about on the previous page. The domain of the first function goes through that first function, and you get out the range of that first function. The range of that first function is then used as the domain of the second function, and then it comes out of the function, whatever it is when it comes out. If this were different, if it would change it somehow, then it would be different, but it didn't change it. So let's look at their example. Okay, example 3, composite functions. For each pair of functions, we are finding f of g of x and g of f of x if they exist. So we're going to start with f of g of x first. Please notice that, remember, you do g first since it's listed second. Now these are ordered pairs, and here is the x value in the first pair. So I'm putting in an 8. I'm getting out a 15 because I go from x to y. Now I take that y value that was my result of g and I put it into f. So I'm taking that 15 and I'm putting it into f. Well, here's an f in the x place, a 15 in the x place in the function f, and what do I get out? I get out 11. So what is my ordered pair here? I started with an 8. I ended up with an 11. Let's look at the next one. All right, the next point, I start with a 5 in g of x. I go to 1 as my y value. So now I'm looking for a 1 in the x place in f. Here it is. And 1 goes to 8. So I started with a 5, I went to 1, then I got to 8. Let's do the next one. Starting with a 10, I go to 14, here's 10, I go to 14, looking for an 14 in the x place here, and that takes me to 9. So I started with 10, I went to 14, 14 took me to 9. The next one, 9 goes to 0, and 0 goes to 13. It might also help to look at it like this. Let's look at this last point again. If I do 9, 0, then it's 0, 13. This is where I started in g of x. This is where I went to f of x. I need these two to match. They basically cancel themselves out and they form the new pair. Looking at the second part of that example then, now we're looking at g of f of x. It can also be written like this, g of f of x, which means you start with f of x and you go to g of x. So this time we will start with the 1 in f of x. 1 goes to 8, and I'm looking for the 8 over here, goes to 15. 0 goes to 13. There's not a 13 over here in g of x anywhere, so we can't even use that point. We just leave it off. 15 goes to 11. Again, there's no 11, so we can't use that one. 14 goes to 9, 9 goes to 0. So when we go in the other direction, g of f of x, we really just end up with 2 points, 1, 15, and 14, 0. For part B of this example, they're doing something a little different. They're giving you two equations, f of x equals 2a minus 5 and g of x equals 4a. Now they're saying f of g of x or f of g of x. Notice how they put the g of x where the x usually goes, and that's exactly what you do. You take the g of x function and you put it into the variable in the other function. Because g is listed close to the x, that's what you are plugging in. So you're taking 4a and putting it into the a. So that's 2 multiplied by 4a, subtract 5, and you end up with 8a minus 5 is the resulting function. If you go in the other direction, g of f of x, now this time you're taking the f of x and you're putting it into the variable position. And since g of x is just 4a, you're taking that 2a minus 5 and you're plugging it in using the distributive property, and you're good to go. Let's look at the check your progress problems. Here are the check your progress problems. Give them a try. Pause the video. Here are the answers. I had to type them because for some reason it's not letting me write on the screen right now. The last example is using composition of functions. Hopefully it will let me start writing on the screen again. In this real-world example 4, using the composition of functions, they're using the problem to talk about a discount versus a rebate. And yes, I saved it, came back into it, and now I can write. Anyway, so here's the discount, here's the rebate, and what they're asking you to do is to apply the discount first. Once you have the discount figured out, then to apply the rebate. On the second part, they're asking you to apply the rebate first. Once you have the rebated price, then to apply the discount, which is cheaper. So you do get different prices by applying them in different orders, and that's how the composition of functions is being applied. Go ahead and try the check your progress. Here is the check your progress problem. Go ahead and try it, and when you're done, pause the video. When you're done, I'll pull up the answer. And here is the answer. We are now done with the instructional part of the video. I hope it was short and sweet enough for you. If you're interested in seeing more on the check your progress problems, you may continue at this time, and they will be explained each one. Explanation of check your progress 1a. You are taking f of x and you are adding g of x. You combine your like terms, you get x squared plus 8x minus 4. Now you are subtracting f of x, subtract g of x. So remember that's going to be x squared plus 5x minus 2 minus 3x plus 2. Now we combine our like terms, and that gives us an x squared, a positive 2x, and a 0. Don't forget to distribute this negative sign through the whole thing. In 2a, you are multiplying x squared times x, and that gives you x to the third, and then x times negative 7x, negative 7x squared, and x times 2 is 2x. Now I'm taking the 4 and I'm multiplying it times each of these things, which gives me 4x squared minus 28x plus 8. I combine my like terms and I get x cubed minus 3x squared minus 26x plus 8. For the division part on 2b, all they do is they take the top function and they put it in the top of the numerator, they put the other one in the denominator, and then And then they also define what x cannot be, so the denominator will not equal 0. Again, whatever's in the denominator, whoops, for that, whatever's in the denominator, set it equal to 0, and that will tell you what x cannot be, because you cannot let the denominator equal 0. In Check Your Progress 3a, I set it up this way so that we have all the points of g of x listed in a nice column. Now what we're doing is we are trying to match the y value with an x value in f of x. So, so the first point I'm going to take is 3, negative 2, and what will be my result? 4, negative 2, because these 3's act more like as a conductor. They cancel each other out. 2, negative 1, I'm looking for the negative 1 pair, and there it is, and so our result is 2, negative 5, and then 9, 4, 4, 7, and so we get 9, 7, 3, 10, 10, 8, so the result is 3, 8. Remember, whichever one is listed second is where you begin. When you try the same thing, going in the other direction, so that you're taking g of f of x, this time you're starting with the f of x points. So here's my f of x points, 3, negative 2, and when you go to find a point in g of x that has a negative 2 in the first position, there isn't one. So we have to scrap that point. Then we take negative 1, negative 5. We're looking for something in g of x that has a negative 5 in the x value. There is none, so we have to scrap that point. That happens for each of the points when we begin with f of x. There are no corresponding x values in g of x, and so they're all scrapped, and so it's all undefined. Undefined because there's just nothing that hooks up and works. In Check Your Progress 3b, if you take f of g of x, another way to write it is like this. It's important because notice that what we're putting in where the x usually goes is g of x, which is a key to how to do this problem. So if we take f of x is x squared plus 2, now what we're doing is we're replacing x with g of x. And so I'm going to put g of x in where the x is, square it, and add 2. That's x squared minus 12x plus 36 plus 2. And combining our like terms, that gives us our function. Now, if we go in the other direction, that's g of f of x, which is g of f of x. So this time we're starting with g of x, which is x minus 6, and we're putting f of x in where the x is in the original function. And so that's x squared plus 2 minus 6. When we combine our like terms, our result is not that different. It's x squared minus 4. On the Check Your Progress number 4, they're wanting you to take it, the rebate and the discount in different order. So you can see here, the first one that I have written down is R of D, which means take the discount and then the rebate. If you get a 15% discount, rather than subtracting 15%, it's just easier to multiply by 0.85. So your discounted price would be $255. Now you get your rebate, which gives you a total of $220. So that would be the first option. The second option is to do the rebate, then the discount. So if you take the 300 and you subtract your 35, you get 265. Now you get 85% of that amount. It's $225.25. So the first option does indeed give you a little better price. And that is it on the Check Your Progress. Thanks for your support.